Ever wondered how to get the most bang for your buck, or in this case, the most space for your fence? Today, we're tackling a classic optimization problem, maximizing the area of a rectangular field with a fixed amount of fencing. Imagine you have exactly 120 feet of fencing. How can you arrange it to enclose the largest possible rectangular area? First, let's visualize our problem. We have a rectangular field defined by its length, x, and its width, y. The total fencing, our perimeter, is the sum of all four sides, 2 lengths and 2 widths. So 2x plus 2y equals 120. Our goal is to maximize the area, which is simply x times y. To do this, we need to express everything in terms of a single variable. From our perimeter equation, we can easily solve for y equals 60 minus x. Now we substitute this expression for y into our area formula. This gives us a function for the area in terms of just x takes sum times dero, a of x equals x times the quantity 60 minus x. Expanding this, we get a of x equals 60x minus x squared. To find the maximum area, we use calculus. We take the derivative of a of x with respect to x, which gives us a prime of x equals 60 minus 2x. Setting the derivative to 0 helps us find the critical point where the area is at its peak. So 60 minus 2x equals 0. Solving for x, we find that x equals 30. Now, we use our earlier equation for y to find the corresponding width. Y equals 60 minus x, which means y equals 60 minus 30, so y equals 30. So the dimensions that give us the maximum area are 30 feet by 30 feet. And the maximum area is 30 times 30, which equals 900 square feet.